The alchemist's dream, when humanity finally learned to make gold. For thousands of years, gold has hypnotized humanity. Kings covered their crowns with it. Pirates crossed oceans for it. Empires rose and collapsed chasing it. Ancient Egyptians buried their pharaohs in golden masks, because they believed gold was the skin of the gods. Even today, in moments of war or economic uncertainty, people still rush toward gold as if it were the closest thing Earth has to eternal security. And for just as long, humanity has dreamed of creating it. The old alchemists had a single impossible wish: turn cheap metal into gold, lead into treasure, dust into immortality. For centuries, that dream was mocked as fantasy. Then science quietly did the impossible. Human beings really did make gold, just not in the way anyone imagined. The metal that refused to die. Gold is strange. Unlike iron, it does not rust. Unlike silver, it does not tarnish easily. A gold coin buried in the ground for 2,000 years can emerge still glowing. It bends without breaking, stretches without snapping, and conducts electricity with remarkable efficiency. These qualities helped make gold feel magical. Long before anyone understood chemistry, civilizations began measuring power with it. The Spanish crossed oceans seeking it. Prospectors crossed deserts searching for it. Legends such as El Dorado, a city supposedly overflowing with gold, sent explorers deep into jungles where many never returned. And somewhere in the middle of all this obsession stood the alchemists. The secret obsession of Isaac Newton. When most people hear the name Isaac Newton, they imagine gravity, planets, and falling apples. But Newton had another obsession: alchemy. After his death, historians discovered that he had written hundreds of thousands of words on alchemical experiments and the mysterious Philosopher's Stone, the legendary substance believed capable of turning ordinary metals into gold. He was not alone. For centuries, some of the brightest minds in the world believed metals could somehow mature into gold. Lead seemed especially promising because it was heavy and dull, almost like unfinished gold. The problem was that alchemists did not yet understand atoms. They believed materials changed through chemistry. But chemistry alone cannot turn one element into another. Burning, melting, dissolving, or mixing metals merely rearranges atoms. It does not change the atoms themselves. To create gold, you must change the nucleus of an atom. And that requires entering an entirely different world. The wall that stopped the alchemists. The difference between chemistry and nuclear physics is far greater than most people realize. A chemical reaction is like rearranging furniture inside a house. The house itself remains intact. Atoms exchange or share electrons, the lightweight particles that orbit the nucleus. Creating gold is different. That is more like demolishing the house, rebuilding the foundation, and changing the street address. To transform one element into another, scientists must alter the nucleus itself, the tiny, incredibly dense core containing protons and neutrons. Standing in the way is something physicists call the Coulomb barrier. Because protons carry positive electrical charge, they strongly repel one another. Forcing particles close enough together to change a nucleus requires enormous amounts of energy. Chemical reactions usually involve energies measured in electron volts. Nuclear transmutations require mega-electron volts, millions of times more energy. The alchemists had furnaces, acids, and imagination. What they lacked was the ability to reach into the nucleus itself. Only the technologies of the nuclear age could finally unlock that door. Gold is born in cosmic violence. Modern science eventually uncovered an astonishing truth. Most of the gold on Earth was not formed on Earth. In fact, much of it was not even formed in ordinary stars. For many years, astronomers suspected that heavy elements such as gold must be created in extreme cosmic events. Today, the leading explanation involves one of the most violent phenomena in the universe: neutron-star collisions. A neutron star is the collapsed core of a massive dead star. Imagine a mass greater than our Sun compressed into a sphere only a few miles wide. Now imagine two of them colliding. During those catastrophic mergers, atoms are bombarded by torrents of neutrons in a process called rapid neutron capture, or the R process. The bombardment happens so quickly that atomic nuclei absorb neutrons faster than they can decay. They grow heavier and heavier in mere seconds. Only afterward do many of these unstable nuclei transform into stable heavy elements, such as gold, platinum, and uranium. Gold, therefore, is not simply cosmic debris. It is the product of a rare cosmic recipe. Every gold ring, every gold coin, and every gold crown contains atoms, forged in moments of unimaginable violence billions of years ago. The gold in a wedding band may have begun its journey in a collision so powerful that it briefly outshone an entire galaxy. The day scientists turned lead into gold. Once scientists understood atomic structure, the ancient dreams suddenly looked less impossible. Lead contains 82 protons. Gold contains 79. Remove exactly 3 protons from a lead nucleus, and lead becomes gold. Simple in theory, extraordinarily difficult in practice. In 2025, researchers working at CERN's Large Hadron Collider announced that they had successfully transformed lead into gold during high-energy collisions. As lead ions raced around the accelerator at nearly the speed of light, some nuclei lost exactly the right number of protons and became gold. For a brief moment, the dream of the alchemists had come true. Yet there was a catch. The amount produced was microscopic, far less than could ever be seen with the naked eye. Most of the newly created gold existed only briefly before transforming again. Humanity had learned how to make gold. It simply cost billions of dollars to produce almost none of it. The hardest part isn't making gold. Surprisingly, creating gold is not the greatest challenge. Creating the right gold is. Gold has only one naturally stable isotope, gold-197. That number matters enormously. Many nuclear transmutation experiments produce radioactive isotopes of gold. These atoms contain the correct number of protons but the wrong number of neutrons. As a result, they eventually decay into something else. A necklace made from such material would not be a symbol of wealth. It would be a radiation hazard. This is the modern version of the ancient alchemists' challenge. The goal is no longer merely to create gold. The goal is to create large quantities of stable, safe, enduring gold-197, the same gold found in nature. Scientists have learned how to make atoms with 79 protons. Making useful gold economically is an entirely different problem. The scientists who beat the alchemists. CERN was not the first laboratory to achieve transmutation. In 1924, Japanese physicist Hantaro Nagaoka reported creating gold from mercury through nuclear bombardment. In 1941, American researchers repeated similar experiments. Then, in 1980, Nobel Prize-winning scientist Glenn Seaborg transformed tiny quantities of bismuth into gold. Each experiment proved the same remarkable point. The alchemists had been wrong about the method, but they had not been wrong about the possibility. Lead, mercury, and bismuth really could become gold. The universe simply demanded a price far higher than anyone had imagined. Why diamonds are different. The modern discussion of artificial gold often invites comparison with lab-grown diamonds. At first glance, the comparison seems reasonable. Both challenge traditional ideas about rarity. But the two achievements are fundamentally different. Diamonds are made of carbon, one of the most abundant elements on Earth. To create a diamond in a laboratory, scientists do not need to create carbon. They merely rearrange carbon atoms into the same crystal structure nature builds underground. A diamond is a manufacturing challenge. Gold is a nuclear challenge. To create synthetic gold, scientists must change the identity of the atom itself. They are not rearranging matter. They are rewriting it. That is why lab-grown diamonds became commercially viable within decades. While lab-grown gold remains one of the most expensive substances. humanity could possibly manufacture lab-grown diamonds or a triumph of engineering. Artificial gold is a miracle of physics. What if gold became common? Most discussions about artificial gold focus on jewelry and investment. But perhaps that misses the bigger story. What if gold someday became cheap? What if future technologies, perhaps advanced fusion reactors or entirely new forms of nuclear engineering, could produce gold as a routine industrial byproduct? The consequences would be profound. Gold's role as a store of value depends largely on scarcity. If scarcity disappeared, much of its financial mystique would vanish with it. Yet another possibility would emerge. Gold might become less important as treasure and more important as technology. Today, engineers use gold sparingly because it is expensive. Despite its remarkable conductivity and resistance to corrosion, only tiny amounts are used in electronics. Imagine a world where gold costs little more than copper. Power grids could become more efficient. Supercomputers could become more reliable. Medical devices, satellites, and communication systems could operate with materials that hardly degrade over time. The dream of gold would move from the king's crown to the common person's infrastructure. Humanity spent thousands of years treating gold as a symbol of wealth. Its greatest contribution might eventually come from being useful rather than rare. The real treasure. The funny thing is that alchemy never truly disappeared. It simply changed clothes. The ancient alchemist worked beside candles and mysterious symbols. The modern physicist works beside superconducting magnets and particle detectors. Yet both are driven by the same desire: to transform the ordinary into the extraordinary. Turning lead into gold was never really about money. It was about understanding reality. And in a way, modern science fulfilled that dream more beautifully than the alchemists ever imagined. Because the greatest discovery was not that gold can be made. It was discovering where gold comes from. The atoms in our jewelry were forged in dying stars and neutron-star collisions long before Earth existed. The gold in a wedding ring is older than mountains, older than oceans, older than life itself. The old alchemists wanted treasure. What humanity discovered instead was the secret history of the universe. And somehow, that may be worth far more than gold.
It's time to study new words in context. 1. Hypnotize. Definition: to hold someone's attention so strongly that they cannot stop watching, listening, or thinking about something. Example: the beautiful sunset seemed to hypnotize everyone on the beach. 2. Tarnish. Definition: to lose shine or become dull over time. Example: silver jewelry can tarnish if it is not cleaned regularly. 3. Snapping. Definition: breaking suddenly with a sharp sound. Example: the dry branch was snapping under the heavy snow. 4. Obsession. Definition: a very strong interest in or desire for something that fills a person's thoughts. Example: his obsession with space led him to read every book about astronomy. 5. Alchemy. Definition: an old practice that tried to change ordinary metals into gold and discover special secrets of nature. Example: many people in the Middle Ages believed that alchemy could create gold. 6. Mature. Definition: to grow or develop until reaching a fully grown or complete state. Example: trees take many years to mature. 7. Intact. Definition: whole and not damaged or broken. Example: the ancient vase remained intact after being buried for centuries. 8. Nucleus. Definition: the central part of an atom that contains protons and neutrons. Example: scientists studied the nucleus of the atom during the experiment. 9. Demolishing. Definition: destroying or tearing down something completely. Example: workers were demolishing the old building to make room for a new one. 10. Alter. Definition: to change something. Example: the tailor altered the jacket to make it fit better. 11. Transmutations. Definition: changes from one form, substance, or element into another. Example: scientists studied nuclear transmutations in the laboratory. 12. Bombarded. Definition: hit many times by something. Example: the city was bombarded with questions after the news report. 13. Liability. Definition: a problem, disadvantage, or responsibility that can cause trouble. Example: the leaking roof became a liability for the homeowner. 14. Torrent. Definition: a large, fast-moving amount of something. Example: after the speech, a torrent of messages appeared online. 15. Isotope. Definition: a form of an element that has the same number of protons but a different number of neutrons. Example: carbon-14 is an isotope used to study ancient objects. 16. Bismuth. Definition: a chemical element, often used in medicines and scientific experiments. Example: scientists used bismuth in their research on artificial gold. 17. Viable. Definition: able to work successfully or be used effectively. Example: the team found a viable solution to the problem. 18. Fusion. Definition: the joining of two things into one. In science, it often means atomic nuclei joining together. Example: the sun produces energy through nuclear fusion. 19. Byproduct. Definition: something produced as an extra result of making or doing something else. Example: heat is a byproduct of many industrial processes. 20. Scarcity. Definition: a situation in which there is not enough of something. Example: scarcity of clean water is a serious problem in some areas. 21. Power grids. Definition: networks of power lines and equipment that deliver electricity to homes and businesses. Example: modern power grids supply electricity to millions of people every day. 22. Degrade. Definition: to become worse, weaker, or lower in quality over time. Example: plastic can take hundreds of years to degrade in nature.
Comprehension questions. 1. Why has gold fascinated people for thousands of years? Answer: gold has fascinated people because it is beautiful, rare, durable, and useful. It does not rust or tarnish easily, and it has long been a symbol of wealth and power. 2. What was the main goal of the ancient alchemists? Answer: the main goal of the alchemists was to turn ordinary metals, especially lead, into gold. 3. Why did Isaac Newton become interested in alchemy? Answer: Newton was interested in alchemy because he hoped to discover hidden secrets of nature, including the possibility of creating gold through the Philosopher's Stone. 4. Why could chemistry not accomplish what the alchemists wanted? Answer: chemistry can only rearrange atoms and their electrons. It cannot change one element into another, because it does not alter the nucleus of the atom. 5. What is the nucleus of an atom? Answer: the nucleus is the central part of an atom that contains protons and neutrons. 6. What is the Coulomb barrier? Answer: the Coulomb barrier is the force that causes positively charged protons to repel each other. Scientists must overcome this barrier to change atomic nuclei. 7. Why does nuclear transmutation require much more energy than chemical reactions? Answer: nuclear transmutation requires changing the nucleus of an atom, which needs millions of times more energy than the movement of electrons involved in chemical reactions. 8. According to the article, where was much of the gold in the universe created? Answer: much of the gold was created during violent cosmic events, especially collisions between neutron stars. 9. What is the R process? Answer: the R process, or rapid neutron capture process, occurs when atomic nuclei absorb large numbers of neutrons very quickly, allowing heavy elements such as gold to form. 10. Why is gold sometimes called a cosmic recipe? Answer: gold is called a cosmic recipe because it forms only under very rare and extreme conditions, such as neutron-star collisions. 11. How did CERN scientists turn lead into gold? Answer: they accelerated lead ions to nearly the speed of light and caused collisions that removed 3 protons from some lead nuclei, turning them into gold nuclei. 12. Why was the CERN experiment not practical for producing gold? Answer: the experiment produced only tiny amounts of gold, and the process required extremely expensive equipment and enormous amounts of energy. 13. Why is gold 197 important? Answer. Gold 197 is the only naturally stable isotope of gold. Artificially produced gold is often radioactive and unsuitable for normal use. 14. How is lab-grown gold different from lab-grown diamonds? Answer. Lab-grown diamonds are made by rearranging carbon atoms into a crystal structure, while lab-grown gold requires changing one element into another by altering atomic nuclei. 15. What does the author suggest might happen if gold became cheap and abundant? Answer. The author suggests that gold could become widely used in technology, power systems, computers, satellites, and medical devices, shifting its role from a symbol of wealth to a useful industrial material. 16. Why do you think humans have always been attracted to gold? Answer. Possible answer. Humans are attracted to gold because it is rare, beautiful, durable, and has long been associated with wealth, power, and success. 17. Do you think artificial gold would lose its value if it became easy to produce? Why or why not? Answer. Possible answer. Yes. Much of gold's value comes from its rarity. If anyone could make large amounts of gold, it would no longer be considered scarce or valuable. 18. Which achievement do you think is more impressive? Making diamonds in a laboratory or making gold from lead? Explain. Answer. Possible answer. Making gold from lead is more impressive because it requires changing the identity of an atom, not just rearranging existing atoms. 19. What does the story of artificial gold teach us about the difference between ancient beliefs and modern science? Answer. Possible answer. It shows that ancient dreams can sometimes become reality, but only after people understand the true scientific principles behind them. 20. What do you think is the most important message of the article? Answer. Possible answer. The most important message is that science not only helps us achieve old dreams, but also helps us understand our place in the universe and the origins of matter itself.